GDP is more influencing. Next is per capita income. Next is this one, right? Now, first point, we have seen what are three variables influencing, right? Now, out of that, which is more influencing, that also we know, right? Now, okay, then we have removed variable, all these things we have done. Now, we have one more regression that is called the stepwise regression. Stepwise, right? So, I'm going to run stepwise, right? Analyze, regression, okay, all same linear. So, sir, why so many, sir? There are all many other regressions are there. That is why the regression is not ordinary. Right. Now itself I am loading. Now itself I am loading more. Right. So if you understand each one, right, how what is regressed, sum of square, all these things, okay, you will get delighted. Right. The formula and all it is given in the PPT curve. Okay. Linear. Right. Now here the method, it is a enter method, right? All values are entered at one stroke. Now let us use the stepwise or forward, right? Forward means it will take one by one. So first it will take forward step. It will take most influencing variable first, right? So that is most influencing, right? So next influence variable next influencing variable, like that it will go, right? Now forward, if you run, okay, you can notice now. Now, see here, coefficient, right? See here, GDP, right? We know already, GDP is the most influencing variable. Now, that is why it is taking, first it has taken that variable, right? Look at the model, first model 1. See, it says, if at all you want to take only one variable, then you take this GDP alone, right? Then you can write one equation with this constant 1 beta, right? Then you can write one equation with one variable. If some people, they want to have only one variable, you take that equation, right? Then that variable most influence. Then next important variable added. What is that? Per capita income we have noticed, right? So that variable added. You cannot remove first. That is most important, right? So now we have another equation with the two variables. This is we can write, this is the constant, this is the beta for this one, this is the beta for this one. So this is beta 1, this is beta 2, right? So multiple regression is O is equal to A plus beta 1 x1, beta 2 x2 plus beta 3 x3. So for each variable, beta, different beta, right? Okay, so now here I will tell that and I will come to this. So this is our multiple regression, right? So this is a beta 1, beta 2, this is x1, different variable. x1, x2, x3, x4, x5, x6. This is beta 1, beta 2, beta 3, beta 4, right? Beta 1 into x1, beta 2 into x2, like that you need to write. So now, okay, so now it is clear that, okay, so when, if at all you want to take only one variable, you have to take GDP alone, you write the equation with the GDP. Then if you want to take two variables, GDP and per capita income, now you write the equation. If at all you want to take three variables, so you take this one. Now, it is not going to the fourth step because we know that it is only three variable influencing, right? So when you run a stepwise regression, right, all you will get, right, it will tell what is the most influencing variable, first point. Okay, not influencing variable, automatically it will be thrown, right? Second point. Third point, right, which is having more, we can find out. Then you can write three equations. right? Not one equation. We can write 3 equations with 1 variable, with 2 variable, with 3 variable, right? Right. So we can identify what are the variables influencing all, right? So stepwise regression is more interesting, more powerful than the ordinary regression. So for everything you will have R square, for every equation you will have one R square, all these things. So whether the one variable alone sufficiently predicting, right? 2 variable alone, okay, fine. Definitely one itself sufficient, definitely 2 will be sufficient only, right? So this is called the stepwise
Excuse me, sir.
regression. Yes,
Lokeshwari ma'am having doubts, sir. Lokeshwari ma'am.
yes, madam. Yeah, yes, madam.
Hello, sir. Hello, sir. Am I audible?
Wait, madam.
Yes, sir.
Madam. Let me see whether I have completed. I hope. Okay, so. Oh. So, what is standardized value? Some descriptive I should assume. So now, if you look at the anti-field book, which I've asked you to read, they will say something, right? So now 10 to 15 cases for each predictor. For what is the sample size? He says, right? Right. For every dependent variable, 10 to 15 cases. Otherwise, another thing, 50 is minimum plus 8 into k. K is a number of dependent variable, right? So that is what he is telling. He is telling, right? Okay. Okay, then tell me, madam, this is the multiple regression, right? All should be metric, right? Yes, ma'am. Yeah. Now you can
Yes,
go
sir.
ahead with the question. Yes.
Thank you, sir. Thank you, sir. Sir, in that result output screen, no, that in SPSS, that constant value, it also gives a significance, right?
Yes, ma'am.
Yes, sir. It should be considered that significance value also while taking up the writing the equation. Like in this case, the value is a little bit is more than 0.05. Does that mean that the constant is not needed, or the constant can be removed from the equation? Is there something like that, sir?
Okay, so it requires a complicated answer, madam.
Okay, sir.
So first, let me tell one by one. The first point, when you write equation is y equal to a plus bx, right? Then definitely you have to write a, right? Definitely you have to write a, whether it is significant or not, right? Then only you will get the estimated value. That is the point number one, right? So because we are going to write the equation with the unstandardized beta, so we are going to predict the values of y with the help of x. Then a definitely should be there, right? But if you do not want to have a, right, you can run without intercept also, you can run, right? Then you will get the beta. That beta will be different beta. So you can run regression, or I do not want to intercept here. Without intercept, right? See, for example, if you go to Excel, you can tell I do not want to have intercept, I want to run. You can tell it will give. That is the point number 2. Point number 3 is very important, right? When alpha, otherwise intercept itself significant, right? It means, right? See, with the help of independent variable, we are predicting the dependent variable, right? Right.
Okay, sir.
So now, what is error? Leave alone that error, right? What is the intercept? See, independent variable influence it is there in the beta, right? Input dependent variable
Yes, sir.
before that beta, right?
Yes, sir.
But when intercept it also significant, which means intercept value capture, it will capture. Okay, but I will change later. Okay, it will capture the influence of the variable which is not included, because with the help of variable this much we are adding something. Why we are adding? That takes care of the variable which we have not included, right? When intercept is influencing, which means the variable which you have not included, it is having a significant influence. So people might question you, right? When you send any paper to any international journal, standard journal, if your intercept value is influencing, then they will question you. Okay, because the variables not included playing a significant role, yeah, which means you have to add some more variable, right? Because they see, it is a publication. They have to be very careful, right? They have to be
Yes, sir.
right. So okay, so which means they will not accept it. They will not accept it.
Okay, sir. So thank you, sir. Thank you so much, sir.
A nice question, madam. Nice question, actually. Okay, you have watched carefully, right? What is your name, madam?
Lokeshwari, sir.
Good question. Good question.
Thank you, sir.
Hello, sir.
Yes, sir.
Yeah, thanks for the explanation, sir. Sir, you said the correlation is done before regression, but
I didn't say, sir. I didn't say like that.
Okay.
I didn't say, sir.
Okay, sir.
What I said, when you have run the correlation, when the correlation itself not significant, I said don't run regression.
Okay. But what is the standard practice, sir? Should I run correlation then regression?
No. See, correlation is not necessary, sir. Right.
Okay.
Regression takes care of the correlation also, sir.
Okay, sir. And one more thing is, sir, most of the places it is linear regression, right? We are fitting a linear model. What if, let us say, if it is not linear, approach, will it be similar?
No. See, we have curvilinear model. Here itself, you have curvilinear model, all these things. Right. So, in a curvilinear model, right, there also we are taking the independent variables. So, the equation is not y is equal to a plus bx. So, if it is squared or cubical, there are many curvilinear models. So, it may be, okay, if you look at if you go to curvilinear model, you can understand what are different nonlinear equations are there, different nonlinear regressions are there, right?
Okay.
So that and all little difficult, sir. Only thing is which here also we can find out which regression you can go. That I can find out by running all the model. Whichever model is having more R square, that is the model you have to prefer. That very easily I can explain, but not necessary, sir, right?
Okay.
So go with the linear model. I am going to use some more models, sir. So
Okay,
that will be very interesting models I am going to tell, sir. Yeah.
And what is the preferred value of R square? Because some places they say it should be more than 0.8.
They are useless, sir. They do not know anything, sir.
Okay. I have seen some papers. Yeah. Okay.
No, they cannot ask, which means they do not know anything.
Okay. Thanks
so
for the.
We do not have any prescribed value for R square,
okay.
Right? We do not have any prescribed value for R. We do not have any prescribed value for chi square value, right?
Okay.
We do not have any prescribed value for difference. We look at the T value, right? We look at the T, right? So T is more, it should be more than 1.96. So what is T? That coefficient or whatever value you estimated divided by standard error. The standard error will vary depending upon the sample size, sir. Right? That is why. Okay. So we see, for example, if you take 10 data, 10 sample size, even when your R square is 0.5, your significant value will not be significant, sir. ANOVA will not be significant, sir. Even if it is 0.5, even it is 0.7, when you are taking only 5 sample, your R square might be 0.8, but your ANOVA says it is not significant. So the matter is not the R square, right? So the matter is the F significance.
Okay, sir. And sir, in stepwise regression, there is no need to eliminate the variables, right? That is what I just added.
Eliminate automatic, sir.
Okay.
What do you want? It will do, sir. If it is not influencing, it will throw.
Okay, fine.
It will not include, sir. See, so it is robust, sir. See, it is okay. So it will do, sir. It will do automatically.
Okay, and one last question. Thank you very much, sir. Should we report all these steps? Let us say in a paper. Okay, let us say I do stepwise, then I do some interpretation. So everything that has been done can be reported, right?
No, sir. No, sir. Right? You cannot do all, sir. Right? You have to use stepwise, or you have to use a simple regression, sir. That's
okay.
all.
Stepwise, if I get 3 equations, I can say under this condition, these are the 3 equations.
Definitely. When you use stepwise, all 3 equations you have to write, sir.
Okay, sir. Thank you very much, sir. It was very okay.
Elaborate, huh? More elaborate. More elaborate, right? See, okay. Because regression is more powerful, more useful, right? You have to use regression, sir.
Okay, sir. Thank you. Very nice explanation.
Still not over, sir. You can take more energy, sir, because I'm going to teach some more. Okay. Difficult things.
Sir, I also have one question. What is the relevance of effect size in correlation? Is it really important to quote it in results?
No, everywhere effect size is important, madam. Okay, so
everywhere. And how can we calculate it, sir?
I do not know how you will get in correlation, madam. But in t-test, all other place, okay. So the effect size will come automatically, madam. Effect size will come automatically. So they are based on effect size. Here in a regression, we have a standardized beta, right? By looking at the standardized beta, we are telling which variable is most influencing, which variable is less influencing, right? So in a effect size, we can find out which is having more, which is making, see, for example, in independent sample t-test, all these things. So which variable is having more impact, that we can tell. Which variable is having more, okay, so that we can tell. But in a correlation, say effect size, I do not know. We cannot, we may not be in a position to calculate because correlation is only bivariate, right? The objective of effect size is, so which is variable is having more impact, all these things. So you may not
just to check the strength.
Yes. So for example, we have seen in a chi-square, right? We have seen in all place. That is we have seen by using pi and gram SV, that is the effect size.
All right, sir. Thank you so much.
Okay, so which means all people have energy, and shall I go to the next one?
Yes, sir. Good evening, sir.
Yes, sir.
I want to know the difference between actual value and standardized value.
Yes.
We calculated standardized now, sir.
Which one, sir?
Standardized value and actual value.
No, I don't understand, sir.
The difference between standardized value and actual value.
Standardized value, maximum value, or actual value?
Yes, sir. Yes. Actual value.
I don't understand your question, sir, but even then...
Sir, when we are going to calculate the regression...
Wait, sir. So this is the standardized value, sir. This is the actual value, sir. Can you see the screen, sir?
No,
No,
sir.
sir. No, sir. Screen is not visible.
So now this is the actual income. This is the standardized income. That's all.
Yes. Sir, the difference, what is the need of this?
No, this value is calculated, no difference. This value is calculated based on this value only.
Yes,
By using a formula, this value minus mean of this column divided by standard deviation of this column.
yes.
X minus X bar divided by standard deviation. Using that formula, it is calculated. Sir. It will calculate, but you need not worry about it, sir. It will, when you save as a standardized value, it will come automatically, sir.
Okay. Thank you, sir. Thank you very much.
Thank you, sir. Okay, fine. So now, so now I will go for, very simple, but I will complicate. Okay. I'm going for a dummy variable regression, right? What is dummy variable regression? So first of all, whatever regression we have seen so far, we have used only the metric variable. Now, we are going to take categorical variable as an independent variable, right? Now, dependent variable is metric, right? But my independent variable is category. That is called dummy variable regression, right? So now let me go slowly, to make you understand. And then we will take up, right? Okay. So now, okay. So let me take a small sample, right? I have typed all the data on my own, yeah. Okay. So see now, okay. Now, okay, I have one dependent variable which is savings, right? So I have taken not visible.
Excuse me, sir. Sir?
Yes, madam. Tell me, madam. Yeah. Tell me, madam.
The screen is clear, sir.
Yes, madam.
So we got it now, sir. Yes, sir. Now it is.
Okay. So now I have one one variable, metric variable, right? Savings. So I have how many data? So I have 16 data. Okay. Wow. First is getting, so total is 17, right? I have 16 data, right? I have one metric variable, right? Now I have one gender, right? I have one gender. Gender means male and female, right? Which is a categorical variable. Right? Now, right? Okay, now, so I will give some information, then I will type, right? See, for a male, right? So out of 60 people, I put 8 male, right? 8 female. The average savings of male is, average saving of male is 1000, right? 437.50, right? Okay, I'll come. So now the average savings, that the 8 people are there, no? The average saving of a male is, please note it down, you have to write it down, right? So the average saving of male is 1437.50. The average saving of female is 1550. Right. So now, if your variable is category variable, then you cannot run the regression straight away. Not possible. In a regression, you have to take only the metric variable. So you cannot take the categorical variable straight away. What you have to do is, you have to create a dummy. You have to create a dummy, right? Right. How to create a dummy, right? Here, automatically there is a procedure to create. Automatically there is a procedure. Okay. So if you go here, right? If you go here, so data, okay. So create dummy. It will okay. So where it is there? So not there. Huh? Transform. I'll right. You can create a dummy, that I will come later. Okay, so I'm not able to see. Okay, some values are there. Create a dummy. All right, create a dummy. You can create. Transform is meant for all. Okay, so okay, create a dummy. Now, right? Okay, so manually we will try to create. Then only you will understand something, right? So first of all, how many dummies to be created? Right, n minus 1. What is n minus 1? If your category variable contains 2 category, then 2 minus 1. 1 dummy you have to create. If your category variable contains 4 category, then you have to create n minus 1, 4 minus 1, 3 dummy. Otherwise, 3 dummy variables you have to create. Right. See, now first we will try to understand. See, now if it is a gender, 2 category, right? N minus 1, okay, which means I have to create only 1 dummy. Let us call that as a male dummy. Male dummy. So what do you mean by male dummy? See, for example, right, we have categorical variable, right? We might be having whether he is a male and female, right? If that person, right, for example, okay, so this person is male. If this person is male, put 1. The second person is female, put 0. What do you mean by 0? He is not male, that is the meaning. Right. So dummy is when he belongs to that category 1. If he is not belonging to that category, then that is zero. That is the way you have to create dummy, right? So here, okay, only two category. One it is male, one if it is female, zero. Right? Otherwise, we call it as not male. That is the meaning, right? Okay. Now, okay, now, okay. So now I've created a dummy. Okay. Now let me run a regression. How to interpret, I will tell, right? So now let me go to the data. Okay, let me go to the SPSS. Okay, so now, okay, this is a dummy. One is male, right? So now this is my dummy is my independent variable, right? So analyze. Now you please remember the mean.
Excuse me, sir.
I will come.
Huh, sir.
Okay, so now, please remember what is the value for male 1437, female 1550 mean, right? Okay, so already noted down. I found the average, right? By using Excel, we can find out that already I have, right? Okay, so now, but whenever you are writing, not necessary. Okay, but first we learn for the purpose of learning, we will use it, right? Now let me use a regression. Now, so create a dummy, right? How to create a dummy? N-1 dummy, right? So now I will come the other things later. First, let me teach. Now my categorical variable is gender, which is having two category. So I have created one dummy, which is a male dummy. Whenever there is a male, I will put 1. If it is not male, I will put 0. Right. Now analyze a regression linear, right? My dependent variable, my dummy, right? Independent variable, right? Now let me say, okay. Now let us look at, okay. So don't look at whether it is significant, all these things. I'm going to interpret, right? Now look at my beta values, right? Look at my beta values, right? That is what is constant, right? Now, when you take a male dummy, right?
Male is constant.
No, wait. When it is a male dummy, for male I have put 1. 0 is the female. So whatever we have put 0, that is called reference category, right? Right. So now, madam, you are wrongly telling. Okay. So now the female mean is 1000, right? I have told you, right? But you should have written down. So without writing, you are telling, that is why you are giving the wrong answer, right? So the female mean is 1550. Now the constant is 1550. Now, which means that is the alpha, A value, right? So A value captures the mean of reference category. That is the first point. So that is the reference category. So the A value captures the mean value of the reference category. So now from this we can understand our reference category is female. The average saving of my reference category female is 1550. That is the first point. Now my variable, right, is the categorical variable, right? That is a male dummy, right? So now my beta is minus 112.50, right? What is this one? Right. So now this means, right, the male, right, they say 112.5 rupees lesser than my reference category. Lesser or more. If it is plus, they say more than, okay, same is my dependent variable, right? So it is not 1 unit increase, please understand. So the average saving of male is 112.50 rupees less than the female. That way you have to. Now look at the mean value, 1437, right? 1550 minus, right? So 112.50, that is the meaning. So 1550 minus 1437.50, that is the right difference, right? So now the beta interpretation is this is this much more than the reference category. So always we will have one reference category, right? Okay, this is this much more than the reference category or less than this reference, right? So now this is the way you have to interpret the beta values, right? Now we will take up the one more example with the same thing now, right? So we will take one more categorical variable, right? Which is the education, right? See, for example, this is the education, right? Let us assume this is my category variable, which is education, right? Right. See, for what we have done is, one is the HSC, two is UG, three is PG, four is no formal education, not studied. That is why we should have given okay differently, but okay we have put like this. No worry, right? We should have taken 0 to 1 to no education, right? Okay, like that. So otherwise, we'll put 4 is a PhD qualification. Let us put PhD qualification, right? So we'll put that is a PhD qualification, right? Okay, we'll put okay, why unnecessary confusion, right? PhD qualification, right? So now we are given a 4 option. One is HSC, 2 is UG, 3 is PG, 4 is PhD, right? Now 4 options are there, 4 categories are there, which means we have to create a 3 dummy, right? Very good. Now this is my category variable, okay? So instead of this category variable, I am going to create 3 dummy variables, right? So first, HSC dummy, right? HSC dummy variable, right? Which means if is HSC, one is HSC, right? If is HSC, we'll put 1. If is not HSC, we'll put 0, right? Right. So we will take PhD is the reference category, right? Which means whoever appear 4 is a reference category that we will take later. So that is why n minus 3, right? Only we will create a 3 dummies, right? The 4th one is a reference, right? Why we are creating 3 n minus 1? Because we are going to consider one as a reference category, right? That is right. So now look at this one. It is a HSC dummy, how I am created. So now 1, all right, which means he is HSC. So I have put 1. Second person is 2, which means is UG qualification, but not HSC, 0. 3 is a PG qualification, so 0. 4th, which is a PhD qualification, 0, right? Like that it goes on, right? This is again a 4, so which means PhD qualification, 0, right? All right. So now Mm. Okay, so now, see, first is HSC dummy, second is UG dummy. So if he is a UG, I will put 1, all other 0, right? So second is UG, right? So now second 1, all other 0. Here second, so 1, all other 0. Third one is a PG qualification. When he is 3 is PG, right? Whenever there is a 3, I will put 1, all other 0. That is why. Now fourth is a PhD qualification. So that is a reference category. I should not create, right? I should not create. Okay, so I should not create. Okay, only 3 dummy, right? So I have 3 dummies. I should not have created. I am telling. So fourth means it is a PhD. That is why I have put that. You should not create, right? So it will come when you do automatically. It will create only 3 dummy. So my PhD is my reference category, right? Very good, right? So now itself, okay, you should to tell me. Now I will tell the mean value for all, right? So my let me write down, right? So the average saving of my PhD people is 1,500. Average saving of HSC is 1,475. Average saving of the UG is 1,400. This is PhD. This is HSC. This is UG. 5,425. My PG is 1,400 and 500, right? 1,575, right? So written. So my PhD is 1,500. HSC is 1,475. This is 1,425. This is 1,575. Right. Now itself, if somebody can tell, if you tell, I will be happy. What is the constant value I will get? What is the beta value for HSC? What is the beta value for UG? What is the beta value for PG? Now itself, you tell, I will be happy. Somebody? Sir, Vivek Gupta, sir, tell sir. What is the constant value, sir?
Sir, constant value has to be 1,500.
Very good, sir.
Of PhD students.
Wait, sir. Now, the constant value should be 1,500. Good, very, very good. Yeah. For HSC?
Sir, that has to be, minus for HSC, that has to be minus 25, I think.
Yes, very good. It should be minus 25. For UG?
Minus 75.
Minus 75, very good.
And for PG, plus 75.
That's all, sir. That's all, right. So which means you understood very, very nicely, sir. Very, very nicely. Right. Very good. Sir.
Thank you, sir.
Now let me run, sir. Let me run. Right. See, let me run a regression. Right. Let me run a regression. Linear. Right. So savings. Let me take HSC. Right. HSC. UG, PG. Right. I have taken. Okay. So See here, the constant value is 1500, HSC is minus 25, UG is minus 75, PG is right. Now how to write? The reference category, the average saving of the dependent variable saving, right? The average saving of my reference category, which is PhD, is 1500. Right. The average saving of HSC people, right? So it is 25 rupees less than the reference category. So you should say comparison with the reference category, right? So they are more or less, right? So minus 25 rupees less 25 rupees. So that is why 1475. So UG is, they are 75 rupees lesser than the reference category. My PG is 75 rupees more than the reference category. That's all. Right? This is the dummy variable regression. This is so, by looking at the reference category, you have to write. You have to write. So now I will tell you, right? See, now we know we know this is our education, right? This is our categorical variable education, right? All right, very good. Right, it is there, right? Now if you take a categorical variable, what is the mistake? Now we know the mean value, all these things, so we have rightly interpreted, rightly it is a result is right. Now if you have taken the categorical variable as it is now, right? I am taking, right? See, linear. Okay, let me not take all, right? So I have one the category variable education, right? So I have created dummy based on education, right? Okay, now let us look at my. So now my beta is 17 rupees 0.5. What is the beta? When you take one variable as it is, when there is a 1 unit increase, 17.5 will increase, right? So now see first one, right? So when you take from HSC 1, okay, when we go to UG, right, 1 unit increase, right, from 1 to 2, right? 1 is HSC 2, right? When you go to UG, 1 unit increase, right? So when there is a 1 unit increase, it says 17.5. Is it 17.5? The difference between HSC and UG? It says more, right? No, not at all. Right? When you move from UG to PG, another 1 unit increase, right? Another 17.5. That is the meaning for the beta. When there is a 1 unit increase, it will increase this much from the earlier one. So your result is wrong. That is why you should not use categorical variable as it is. You have to create a dummy, then only you have to create this one, right? Many place dummy variable representations are used. Okay. So see, for example, when you take a categorical variable, right? Normally what we will do, one category variable, one metric variable, we can perform ANOVA. That also we are talking about a mean, all these things. But when you run a category this one, and when you write, all right, so by using dummy variable, so the acceptance will be more, right? So try to use dummy variable, right? So whenever you say dummy variable regression, it is having more attraction. It is having more attraction, right? Very good. Okay, that is one. Now, this is most important. This is very easy to dummy variable, right? Now I am going to tell most difficult one, which is I am going to take my dependent variable category, right? Right. My independent variable, it can be metric or it can be category, right? Now, if it is a category, automatically it will create a dummy. All right. Category means I can use, right? But I have to tell that variable is a category. When I say that variable category, it will create a dummy. Only thing is I have to tell, automatically it will perform. But my dependent variable is category. Right. When my dependent variable is two category, it is binary logistic regression. When my dependent variable is 3 and more, that is called the multi-nominal logistic regression, MLR. Right. So this is robust. Why it is robust? You need not, for regression, we have many assumptions, 6 assumptions, 7 assumptions are there. 7 assumptions are there. All right. So now see, for example, if I take eViews class, all right, first I will run regression. I will say my eViews are the econometrics. eViews is econometrics. So my econometrics is nothing but regression, I will tell. I will say my eViews is nothing but the regression, right? Immediately, I will say regression, I will show this one. Immediately, I will tell assumptions for regression, right? Right. Then, if you are not able to meet one assumption, right? So, like, for example, homogeneity, heteroscedasticity, right? So, normality, like that. Okay. So, when you break certain assumption, then don't run this regression. Go for arch, go for gauge, like that I will tell in that class. In that class. So many regressions are coming when you break the assumption, right? Right. So now here in this multi-nominal logic, that is binary logistic regression, you need not worry about the assumption. You can include the categorical variable also, right? So it is a most very interesting technique, right? Output are very less, interpretation also very simple, but logic behind that is more complicated. But I will try to explain in the most simplest form, right? I will tell the logic. Logic is not necessary, only interpretation you are going to write. But if you understand the logic, you will appreciate. You will appreciate. But not necessary, yeah. Okay. Only thing is how to interpret, right? So whenever you get categorical variable, you have to, that is why I taught dummy, right? You have to write like what you write for dummy, right? From the reference category, this is more or less, like that you have to tell, right? Then, okay. So now, okay. So now what is my situation? What is my situation is, what is my, that is a binary logistic regression or simply logistic regression. Logit regression. Logic. We have logit, propit, topit, many things. Here itself there are many, right? Okay. So many regression is many, yeah. Okay. Because we want to predict different situations, right? That is why many people working on it and they are giving some robust, some technique so that we can increase our predictability, or otherwise we can reduce our error in prediction, or otherwise we will reduce the residuals, right? We want to increase the accuracy of prediction. Accuracy of prediction, right? So that is why people go for more and more, right? So very good. So my dependent variable is my screen visible? Emma?
So we can see your only output.
Okay.
Sir, last 5 more minutes left.
No, we will go, madam. We will go. Okay.
Yes,
Because, okay, so let them, okay, come prepared. So tomorrow morning, somebody please call me, madam. Okay, so that I will share this one, right?
Yeah,
So,
sure, sir. Sure.
please call me.
Okay, fine,
10
sir.
o'clock, 11 o'clock, please call me so that I will share. Okay, tonight also I am traveling. Okay, so I cannot do. So now, okay, my dependent variable is category and binary. Binary means 0 and 1. My independent variable may be category or metric. Category means it will create dummy. You need not worry about, okay, normality assumption, right? Now, my dependent variable is 0 and 1, which means my beta is okay. I cannot tell when there is a 1 unit increase, this much will increase, but my dependent variable is 0 and 1, right? I cannot tell when there is a 1 unit increase, this much will increase. No, right? So now what to do? My dependent variable is converted into probability. Okay, converted into probability. Probability of coming. Okay, so for example, whether you possess house or not. If you possess house, 1. If you do not possess house, 0, right? So now I want to know what are some people, they are having own house, some people they do not have own house, right? I want to know what are the factors influencing the possessing of house. So some people they smoke, some people they do not smoke. What kind of people are smoking, right? What is the influence of people on smoking? Some people they have cancer, some people do not have. See, many study on medical field. Some people are having cancer, some people do not have cancer. We want to know what are the factor influence. So okay, if we take some people, they are having cancer, some people they do not have cancer. Now, what is their age? What is the food habit? Where they are living? So, what is the carbon content in that place? So that we can find out what are all the factors influencing the cancer, right? So now it is not cancer, it is the probability of getting cancer, right? We will change it, no worry. Now that is converted to odds. Odd, that is the very important word we will use. Odds ratio. Okay, odd means probability of getting cancer and 1 minus p, right? What does it mean by 1 minus p? Probability of not getting the cancer, right? P is when it is a probability, 1 minus p is not getting, right? Probability of possessing house and divided by probability of not possessing a house, right? You need not worry. You need not worry. You run, it will do automatically. No worry, right? Okay, so we are going to run, we will be using these words. That is why I am telling now. Now, that is converted to log of odd. Okay, this is odd. When you take log, that is a log of odd, right? ln of, that is a natural logarithm of p divided by 1 minus p. That is a natural log, which is nothing but logit. So my dependent variable is ln into p divided by 1 minus p, right? Which is equal to a plus bx, right? So my dependent variable is ln of probability divided by 1 minus probability. 1 minus probability of not getting. One is probability of getting, another is probability of not getting. So since my dependent variable is log of odd, so this we call it as logit. Log. That is why logit. So logistic regression. Right. Very good. Okay. Now, right. My equation is, this is my equation, right? P probability divided by 1 minus probability of getting smoking. Anything you can use. right? After attending workshop, you take some data, you run it and send paper. Acceptability is more. Acceptability is more and more, right? You can use it for anything, right? People are looking for it. Who are getting cancer? Who are getting or not getting house? Who will purchase? Who will not purchase? Who will get admission in foreign country? Who will get admission in IAM? Like that, you can study, right? Very good. So now my equation is odd. This is odd, ODD, odds ratio. Since it is ratio, odds ratio equal to E. Okay. To the power A plus BX, right? See, when it is and log, when you take on the log, fine, right? Right. When there is a exponential, to remove exponential, if you take log, the exponential will be removed, right? Right? How to remove exponential? If you take log, it will remove. So that is why I'm taking a natural log this one, okay, which is equal to this one. That since this is my dependent variable, so we call it as a natural log. So logit z is equal to ln of probability of getting admission divided by probability of not getting admission, right? Why this one? Why we are doing, right? Okay, before going there, okay. Now, how to convert the probability? Probability equal to odd divided by 1 plus odd. That is the probability. Probability of getting admission, right? I will demonstrate all. So, P is equal to odd divided by 1 plus odd. So now we said odd equal to, right? P equal to, that is the odd. Please, when I say odd, please do not pull me my legs. Odd is equal to probability of getting admission divided by 1 minus probability of getting admission, otherwise probability of not getting admission, right? When probability of getting admission divided by probability of not getting admission. That is my odd. So odds is equal to e to the power a, e to the power, right? A plus bx, right? So now odd divided by 1 plus odd. So odd is equal to e to the power a plus x divided by 1 plus e to the power a plus x, right? So these are all we will be using, right? So why it is taken, you will understand, right? See, when you take probability alone, what will happen is probability start from 0 to 1, it will increase. So when you take odd also, what will happen? So, okay, so probability divided by 1 minus probability, which is 0. So which is this one, like this, it will go. So suddenly it will jump. So infinity it will go. So this also we cannot do. But when you take log, so look at this one, from minus 4 to plus 4. See here how it is going. Minus 4 for a different probability, right? Probability divided by 1 minus probability, right? So when you take a log, so it is ranging from minus 4 to plus 4, 5. So which means it is going this one. So which means when it will increase, when it will decrease, we can easily find out, right? So it is slowly moving. Now see here, if you use odds alone, 9, 99, like that it goes, right? So that is why we are going for a logic, right? So now we will take the data set. Okay, so I will take up all these things tomorrow, right? So now if you have any question, you can ask, otherwise we will leave it. Okay, so tomorrow I will teach this binary logistic regression. Very good, sir. Right? Yes, sir. Any doubt? Otherwise we'll close, sir. Any doubt? No doubt?
Participants, if you have any doubt, unmute yourself. The two of them have raised their hand. Chandra Kumar sir and 15, I could not say correctly.
So my connectivity is poor or Rohini madam connectivity is poor?
Rohini ma'am's connectivity is for us.
So I am sitting in my native place. I used my mobile. Okay, very good.
can unmute yourself and ask your question.
Okay, Chandrakumar sir.
Hello, sir.
Yes, sir.
Thank you, sir. Sir, only thing query is any papers of yours and your scholars, if it is available online, we would like to refer so that we can learn more. Or maybe the completed PhD thesis of your students, if it is available online, we would like to refer, sir. That's it. That is what I wanted to.
No, sir. See, you can look at the South Ganga, sir. So my PhD scholars, the thesis are visible in South Ganga. Okay. So how to proceed slowly? You can see, for example, in Bangalore itself, we got Tilak Venkatesan, sir. He has written one day mail. Sir, I have seen only your research scholars. Praveen's thesis are nicely written. So like that. Okay. So you can go through those theses.
Okay, sir. Okay.
Apart from that, instead of going through that, go through the PPT, sir. That will be more attractive.
Okay.
Okay, sir. Seema, ma'am. Seema Dande. Yes, ma'am.
Hello.
Oh,
yes,
sorry.
sir. Yes, sir.
Yeah. Okay, sir. My very simple question, but just in order to find out the t value. Okay. So in order to find out the t value, we are doing all the study regression, everything we calculated, and we are compare that value with the reference t value. Just I don't understand, sir, that reference t value in the last slide, means yesterday's slide, you have compare it with, that is 1.96 was the factor, which is a 95% of the confidence level. Okay. Just I want to know that reference value, how we can get that. Hello.
Wait, sir. So I'm showing the T table, sir, right?
Yes, sir.
Since it is one value, everybody they will tell, sir. Okay. So now my some PDF is visible.
Yes, sir.
Okay. Now my Z value or T value at 95%. What is the value, sir?
1.96 is there.
That's all, sir.
Yeah.
Okay.
So this is this data.
99%, 2.58, right?
Yeah. Suppose my point of interest is some particular value, so I have to compare that value with the maximum, that is 95% of the probability, right, sir?
Yeah. There is a logic, sir. Why we are worried about 95% is we are looking at this two standard deviation. So whenever you take any normal distribution, sir, right? In a normal distribution is right.
Okay.
Wait, sir. See, look at this one, sir. So this is the normal distribution curve. In a normally distributed environment, when you take mean, this is the mean value, sir. Mean, one standard deviation this side, mean. See, for example, mean age is 32, right? Yeah. Right? Mean age is 32, right? When our one standard deviation value is 2, right? So, 2, right? 32 plus 2, 34. This side minus 2. So from 30 to 34 age when you take, right? So it will account for 68% of your data.
Okay.
So when you take 2 standard deviation, 95% of the data. When you take 3 standard deviation, it will cover 99% of the data. So we want to look at the 3 confidence interval. So 95, 99, because we want to accommodate whether 2 standard deviation or 3 standard deviation, right? I will normally explain right? If you are a management faculty, you might have studied in the statistical quality control paper, where you might have seen SQC techniques, P chart, X bar chart, R chart, all. They will take, if it is a R chart, we will take R bar, that is the central line, right? Upper line is R bar plus 3 standard deviation, right? Down is minus 3 standard deviation. So when it is within these 3, upper limit and lower limit, we will accept. If it is beyond, we are rejecting, right? So if it is within this one, that is the normal, right? If it is beyond that, so we will reject. That is why 5% we are rejecting when it is this side and this side.
Yes, sir. Understood, sir. Thank you, sir.
I will explain, sir, slowly, but that and all we are not using much. That is why whatever required to write, I am telling. Otherwise, I used to tell what is normal distribution by taking one interesting example like boys and girls. I will take and I will tell, sir. But okay, so since that is not that important, it is only for knowledge. But we are worried for something else, that is why I have not covered, sir.
Okay, sir. Thank you very much, sir. Thank you.
For everything, there is a logic, sir.
Yeah. Yes. Thank you, sir.
Yes, sir.
Hello.
Yes, sir.
Sir, my question is based on the logit model. Log codes means, sir, beta value, logit beta value, sir. Log codes.
No, sir. There, beta value is dependent variable is logic, sir. My beta is beta only. See here, sir. Right. If you look here, right. Look here, sir.
The screen is not visible, sir. Okay.
Now here, see, my beta, this is beta, sir. B is beta, yes or no? A is beta.
Yeah.
So B is beta only, sir.
Okay. Sir.
B is beta. My dependent variable is this one. So whenever I explain, when there is a 1 unit increase in here, I should say this much logic increase, like that I have to tell. That I will come later, sir. That is why I am taking, how to write interpretation. That is why I'm giving this much explanation later, sir.
Okay, sir. I think this is represent the marginal effect, sir, or not?
Marginal
effect in SATA. Using the SATA, the marginal effect is one more output, sir, in logit model. But in SPSS, marginal effect is not shown, sir.
No. Marginal effect is the beta, sir. What is beta is marginal only, sir.
Okay, sir.
So what is marginal when there is a
1 unit increase?
That is the beta, sir.
Okay, sir. I got it. Thank you, sir. Thank you so much.
Okay, Rohini madam, we will stop. Thank you, madam.
Sir, Kashalingam sir, thank you so much for sharing wonderful information today. And now I would like to ask any two participants would like to share your views on today's entire 9 days of FDP.
Madam, I'm happy today. See, when I shown the dummy variable recursion, one sir has given an excellent answer. So I'm happy. Okay, so I'm really happy when I heard that answer, right? So,
sir, Nagalakshmi ma'am is here, sir. Yes.
Good evening, sir.
Good evening, madam.
Yeah, sir. I'm very happy to be a part of this FDP. During lockdown period, I have been attended many FDP's workshops, but I haven't came like expert like you, sir.
Okay, madam.
You are giving the minute to minute part. Even the expert person and even the basic learner person, both can learn at the equal level of learning. Was I felt by attending these 9 days sessions. And in the Nandini's ma'am, when you are giving more trouble to Nandini's ma'am, in that sessions I was learned everything. Whereas coming to the last sessions, I was just listening and trying to understand and trying to make somewhat practice. But it's really
madam, I want to trouble Nandini madam. She is not ready. She is escaping. Now what to do? Then you have to blame that madam, not me, madam. Okay, so that madam, she has internet connection. What to do, right?
Yeah, but we learned a lot during the first 5 days.
Right.
You are meeting Nandini ma'am again and again. We are able to set answers by our own. This one is this one, this one is this one. So we are getting how this calculation we are doing. I never came through the SPSS sessions like this. I know how to run it, how to calculate it, but I don't know the background story of these all interpretations. And really I am very thankful to be a part of this. One small request, sir, that just share the soft copies of research methodology by Naresh Malhotra, sir.
I will share. You ask everything to the Nandini madam or Sivakumar sir. So let them call me, and tomorrow whatever they are requesting, I will share. No problem. Nothing is secret, madam. Nothing is secret. Okay.
Yeah.
So only thing is, don't tell I have given anything to you. Okay, you have taken like that. Anything material also, I do not want to get me the name. So if you learn, it is fine.
Yeah, sir. I have started using the sessions of you like these 4 data things to my students also.
Tomorrow I will definitely share, madam. I have past few days I have not shared. Sorry, I should have done, but since I am busy and moving, the internet is not that great. I could not do. Definitely I will do that. Definitely I will do.
And I have given the same examples to my students. They enjoyed a lot research methodology sessions by us.
Very good, madam. Very good. Very good. Thank you, madam. Thank you. Learn the logistic regression, madam. Then you will understand what is the mathematics behind.
Yeah. And I thank and congratulate the team of organizers for such a nice FTPs. And we request for further intimation of the programs, especially by Kashlingam, sir.
Thank you, madam. Thanks.
Definitely, ma'am. Thank you, ma'am.
Thank you, ma'am.
And Tilaga, I think Tilaga. Kindly.
So,
yes.
Ma'am, can you hear me?
Yes,
Yes, madam. I could hear you. Yeah.
So, Vanakkam, sir.
Vanakkam. Yes, sir.
So, the same Tilaga who attended in Jai Shri Ram, if you remember me, sir.
Okay. Your name, madam? Tilaga.
Tilaga.
So, that Jai Sri Ram, I have taken Amos, right, madam?
Yes, sir. Yes, exactly, sir. You're right, sir. So, when I started again from the basics, it was நிறைய விஷயங்கள் வந்து இப்போ மேம் சொன்ன மாதிரி like we have started from the basic scratch again, sir. Whatever we wanted to teach the students, like we are getting it in depth, and we are getting it analyzed from our point. Okay, we have to do this. We have to take only that significant value we will tell them. This is how you have to get it analyzed. But now each and every point, ella point, over chinna vishayangalum we are trying to teach them also, and we are making them okay. These things are to be included in small conference paper. ஏதாவது ஒரு conference paper நீங்க போடும்போது இந்த மாதிரி சின்ன விஷயங்களை சொல்லி போடுங்க அப்படின்னு சொல்லும்போது like really satisfying, sir, from our side also. And thank you so much, sir, for this.
Madam, I am also a student. I am also learning. I am also a researcher. I am also publishing. So I am also a reviewer. I am also all. No, madam. So now I am looking at from every perspective, madam.
Exactly, sir. Exactly. And your teaching is really good. Even the layman can understand statistics from you, sir. That is the main thing. Even if they don't have any knowledge about it, they can really understand it really well, sir. Adhan, sir. Thank you so much, sir.
Thank you so much, madam. Thank you,
ma'am. Thank you, sir. Thank you, organizers also. It was really interesting for the last 9 days. Even we have household work, but still, we are not able to leave the session and go because we don't want to leave any bit of it, sir.
Sorry, madam.
No, sir, we are actually thankful to you, sir. Actually,
it is your precious time to sit in the family, share with your.
No, sir, it's again, this is, we are not. Only 10 days we are spending, no, sir.
Yeah, very good, madam. Nice attitude. Very good. Thank you, madam. Good idea.
Thank you, sir. Thank you, sir. Thank you, sir.
Madam, we will close, madam. Tomorrow.
Yes, sir. Yes, sir. Thank you, sir. Thank you so much for your enriching today's, especially knowledge towards SPSS, sir. Once again from our end. And again, I also thank the organizer, that is our research cell coordinator, Shukumar sir, and our principal, Professor Jairam sir, and all the teams again who are directly or indirectly supporting for conducting this FDP. And I also thank all dear participants. And let us meet tomorrow in the 10th day, the last day of our FDP program. Thank you, everyone.
Thank you, madam. Thank you very much. Thank you. Okay. Thank you, madam.